So we want to translate all these equations, all these scenarios into equations. Just recall that writing a system, what does that word mean right here? System of equations? Okay, that just means two equations. In this context, when you guys are in Algebra 2, you're going to have more. You're going to have 3 equations, and in higher classes you can do even 4 equations, 4 variables, and lots of different scenarios. But we're doing just the basic. So expect 2 equations. And one way to start here is that, well, what are the 2 equations about? So you'll see right away, like on number 1, well, we're probably going to have an equation for Ted, right? We have one equation for Ted, and whatever information we have about him, and then we'll have another equation for Ara. If you read like number 2, it says 2 countries are keeping track, right? In the country we need oil, okay, barrel costs this, and in another country we have oil. So you have to know, okay, I got 2 different countries, therefore I have 2 different equations, so just kind of getting the feel, what are the 2 equations about? Two different something going on. Right. So Ara is saved $1,477 and is saving $64 more each payday. Ted has saved $948 and is saving $87 each payday. So let's go back and try to review a little bit some information. From the beginning, I'm just going to write a few notes right up here. We have this y equals mx plus b, slope-intercept form, right? And writing the equation of line was always about figuring out, well, what is the slope? What is the intercept? Right? Intercept. And what are some key words that give it away that a number is a slope? So looking at this, what are some key words that say, like, well, this is the slope because it has these words, and this is the slope because it has these, or y-intercept. Okay? So one of those was that each. Like $4 each day, each year, something like that. Another way of saying it would be per day, per year. Something that shows that it's increasing or decreasing, increasing, decreasing. Something that shows that this is how much is going up or down every month, year, something like that. And then we have the y-intercept that was like a starting point. And there's different ways of saying starting. Other ways would be like initial, the initial balance, or I started with, or lots of different ways of saying, well, here's where we're going to start at. And then the slope is, well, here's where we're going. Again, this much more, this much less every year, every month, every hour, whatever. So if I said you made $10 per hour, you could say, okay, that's a slope because that's how much is going up each hour, per hour. And you'll find similar but not the same language throughout all these, and you have to just figure out, well, how can I write it in the proper format? Okay? In general, what are we doing for this whole week? Okay. You're going to be graphing 2 lines or solving 2 equations, which is called solving a system. Right? And you're going to be trying to figure out, where do they intersect? This is where both are equal to one another, where they're the same. And this value of x will tell you one thing, like how much, how many, and this will tell you, like, this value of y will tell you, like, the cost. So all this, every single problem we're doing this whole week is going to come down to this. Okay? There's a special word for this right here. It's called the breakpoint. sometimes called the break-even point, meaning at one point one costs more than the other, but eventually they cost the same, they're even. And then afterwards, you can see here like the blue line, this is going to be less since it's below the red line. But then after a certain point, after this break point, all of a sudden the blue is more. It's above the red line. So it's a special value. And one way of interpreting this is that, okay, this company is cheaper right here, but then after a certain point, this company is more expensive. And you want to know, when does this company become more expensive, or when does this cost more? Okay? Usually for financial reasons. Okay? So we're always going to be trying to figure out what are the X, what is the Y, where they intersect. Where are they intersecting? That break point. Okay. So keep this in mind on every problem we do. This is what our goal is. And I'm going to show you 3 different methods for actually figuring this out. Today's going to be one method. Wednesday will be another method. Thursday and Friday will be a third method. So going back to here, okay, so ARA, okay, that's going to be the second equation since I moved it 2. ARA saved $1,477, and to start off with, right, she just has that, so that's a good hint that starting off with that. And she's saving $64 more each day, each payday. Okay? So it goes along this line. It's like, okay, each day, okay, that's like a slope. It's going up by $64 every payday, which might be every month or every 2 months, we don't know. So adding 64x. Now we could also write this the other way around, which would be 64x plus 1,477. So that's what you're going to be doing on these, is go through and take each of these, add them into equations. But it's all about language. It's all about looking at language. Okay. All right. You save $948, but it's saving $87 each payday. Okay. Again, that could be written the other way. Now, if you want to use different variables, like for payday and for dollars and things like that, that's fine. Or you can use X and Y. And we're going to stop here at this point once we have the 2 equations. But just remember, well, hopefully you can see this and kind of understand that, well, Ted here, starting with less money, but is saving more every month. ARA is starting with more money, but is not saving as much as Ted. So if we were to graph these, okay, so this might be Ted, starting at $948, going up $87 every payday, and ARA is starting higher at $1,477, but not saving as much. So at some point, right, these 2 are going to intersect. We want to know, when is that happening? Okay, how many paydays? That's what this would be. How many paydays? And then also, once we go over here, how much money will they have saved once they have the same amount? How much will be saved up for both of them? We're trying to figure that out. Because after this point, Ted's going to have more money. ARA's not saving as much, so as long as Ted keeps on saving more than ARA every month, at some point, he's going to have more money. When is that going to happen? We want to know. That's a general question for all of these. So, reading number 2, go through and say, okay, I have 2 countries. We got this one, right? And go ahead and label them and do like I did here. And come up with 2 equations. And look for the similar language. Like here it says $64 more each payday, or the slope here, right? But down here it doesn't say more dollars each payday, right? It says $0.08 each day. So the language may not be the same, but it's going to be similar. And try to see that pattern throughout all these problems, and that'll help you come up with the equation. So the first, we need oil. Barrel costs $40.05, right? And it's going up by, it increases by, right? Again, you're looking for those key words, increasing by 8 cents a day. I know that's my slope, so that should have the X on there. All right, go ahead and do as many as you can on this front side. Check with someone next to you. Make sure you guys are kind of getting similar answers. Remember, there's kind of two ways of writing the same equation here. It doesn't matter which one you use. And it's okay if you use different variables other than X and Y. Okay, just make sure they're different. Don't use B for barrel on both of these because they both have barrel. Okay, you use something more specific. Okay. All right, go ahead and do that now. It'll take about 3-4 minutes to either practice that and check with one another. Okay. So in number 6, we're talking about, we still have a system because we're talking about 2 people. Right? So we still talk about Adam and Kayla in this sense. And they're doing this fundraiser. Customers can buy plain wrapping paper and shiny wrapping paper. So we're not really talking about a slope and a y-intercept, but we're talking about 2 different items. Now, we did this already, and it's actually an extra credit question on the quiz. Right? And it was called standard form. We had something called standard form. And we did it on the 7-Eleven and the Virgil Bonanza and all those word problems as well. We have standard form, which kind of looks like this. And A and B, okay, are 2 different items usually. Okay. And they can give you how many of each item, like they do in number 6. They can tell you, well, this many shiny, this many plain. Or they can tell you the cost of each. Okay. But yeah, we're talking about 2 different items. And then over here is usually the total of those items. And same thing, it can be the quantity total, or it can be the cost, the total cost of all the items all together. So we have the slope-intercept form where they give you, well, here's where you're starting, here's how much you're making. And then we have the standard form, which is, well, we have 2 different items, how do we graph it? And before, I think we had for one of those problems, I think it was 7-Eleven, we had $3 Gatorades, right? And maybe $1 waters, right? And we spent a total of $8. And the equation was simply, okay, that's 3x plus 1y and adds up to $8. And that's the standard form. So if you have 2 items, this is the fastest way of writing an equation. If you know how much they are, or sometimes they say, well, I bought 3 Gatorades and I bought 1 water. It could be the price or how many there are. So a quick way of finding this, and then we could go ahead and solve this in slope-intercept form and graph it if we wanted to. Okay. So tomorrow is going to focus on, well, what if the problems are like 1 through 5? There's a nice method that works if the equations are written this way without graphing. And then on Thursday and Friday, there's another method that works really good if it's written in standard form. So that's why we have, all these different methods. We have the graphing. All of them we could graph. But as you saw in number 2, would you really want to try to go ahead and graph 40.05 y-intercept with a 8-cent slope? It's not going to be easy. You can't really see just by estimating where they exactly intersect. So we'll have these other methods that'll let us know exactly where they intersect, and we don't have to go through graphing. So on this particular problem, going back to number 6, we can buy plain or shiny. Okay, so atom, I'm going to use my first equation, it's going to be atom. Okay. Sold 8 rolls of plane. So this one we're talking about the quantity, how many of each, as opposed to it's $8 for a plane. It says how many. So we have $8 for a plane, plus 7 for shiny. 7 rolls of shiny. And we know that's going to add up to a total of $212. And then we do the same thing for Kayla. She sold 11 of the planes and 14 of the shiny, which added up to $379. So in either case, on the front and back, we have 2 equations. That's a system with 2 variables. I have to have 2 equations, and I have to have 2 variables. The variables here are the cost of the plane and the cost of the shiny. We know how many they bought. We know what it adds up to, but we don't know, well, how much is one cost. How much is one plane and one shiny cost? That's what they don't tell you. That's what you, if we go ahead and graph these, and which you won't really graph these types, but if we did, okay, you'd be finding out, well, when do they cost the same? How many plane, how many shiny would it take for them to cost exactly the same amount? Alright, so using that, go ahead and translate a few more of these. You can see they're similar, like on number 6 we have plain wrapping paper, shining wrapping paper, but at number 7 we have a rose bush and we have ivy. So they still give you how many of the rose bush, how many of the ivy, and then the total cost. You really have to focus on language. Some people want to do order, and that really messes you up because you might say, well, okay, the first number I put first, second number I put second, and the last number I put third, but here they give you the cost first. Here they give you the cost last. So you don't want to say, well, let me just look at the ordering and ignore what the words say. You want to always put the total cost at the end. So no matter what, total cost always put at the end. Doesn't matter what order it comes in when you're writing, when you're reading it. It always goes in the same place. So go off the language, not the order. Okay. And I'll leave this up here. Yeah, if you need to copy that down to information to have. Okay, going down here. So here's what we just practiced was really the first half. So if you just take the first few sentences here and turn them into a system of equations, that's part A. As I mentioned earlier, we're really concerned about part D. When are they going to be the same? Like after how many DVDs in this case, and what is that same price going to be? We want to know that. So one's going to be cheaper for a while, but then at some point that cheaper one becomes more expensive. We want to know exactly where that point is so that I could change companies or only rent a certain amount of DVDs and not, spend more money than I have to. So reading this, you can see, okay, dancing, film and recital. 2 companies have compared prices for film and recital producing DVDs. Raw production charge is $2 per DVD plus $20 to come to the film recital. So they have to go out there and just set everything up and then hit record. And then they, for $20, and then for every DVD they make after of the actual recital, they charge $2. Then there's this other company, Cat Media, same principle, but they only charge $10 to come out, which is cheaper. They charge more per DVD. So let's say I only charge $10 to come out, but it's $4 for every DVD. Now, decide which company to use. The dance team wants to determine the number of DVDs that would make the 2 options equivalent in terms of cost. So at some point, these are going to cost the same, but how many DVDs does it take for them to cost the same amount? So kind of like what we started with the very first problem. Yeah, the first one is cost more up front, $20, but it's less per DVD. The slope is different than here, where yeah, this is less here, but it's more per DVD. So at some point, these are going to end up costing the same. You want to know when. So let's do the first equation, and that be Rob's. Okay. And that's right here. So it's $2 per DVD. Is this the slope or the y-intercept?
Y-intercept.
Slope, y-intercept. So use your notes. Let's back up here. Okay, each per. Now, when you see that, you know it's a slope. Okay. So that's the most important part. If we don't do this correctly, it won't matter how we graph it. It will never work out right. $2 for every DVD plus the initial $20 to come out. So you notice how in the other problem it gave you the y-intercept first and then the slope. That's why you can't go on order. Oh, the first number must be the y-intercept. Well, the first number must be the DVD. You have to read the language and see where it is. Okay. And then here we have Chad. And looks like he is going to be $10 to film. $10 to film plus $4 for every DVD. Notice how they gave us the information in different orders. Again, you can't go on the order. You have to look at the language. All right. So it's good to note that in this problem, it's $2 for DVD, $4 for DVD. So we want to keep in mind while we're doing this that the X stands for DVD. Again, at the end, we want to know what does it mean, not just say, well, the answer is this. Well, what does that mean? Well, I don't know. So that's the answer. It's not good enough just to say it's an answer. We want to know what it means. And here, that must mean the Y is cost. $10. We have to know what X and Y stand for in order to, when we get our answer, know what it actually means. So when will the two options be the same? How much will many DVDs will that be? So how many DVDs? Our DVDs are X. So I'm looking for, to answer this question will be, well, whatever X equals. How much will it cost? The cost is Y. So we have to translate this to, well, they want to know DVDs. What variables does that mean? It has to be one of those things. So once I figure out where these intersect, I'll know what my two values are. Note how there's two answers. They want to know two things. There's two variables, so you have to have two answers. X and Y. All right. How do you graph this? What should I count by? Two's on the bottom, so I go 2, 4, 6, 8, 10?
Yes.
Like that? No?
On the left side.
So you might have to mess around with this a little bit. And if you try going like the number of DVDs, 1, 2, 3, 4, 5, 6, and so on, and here you do 2, 4, 6, 8, 10, 12, and so on. Well, let's see what would happen. 14, 16, 18, 20. If I tried to graph Rob, Rob is starting at 20 and going up 2. So here's 20, and if I go up two more dollars, that's going to be right here. So that really doesn't help me. I can't see where these intersect. And then Chad would be right here, $10, but going up 4, right? And if I follow this slope, you can see that I can see that they're eventually going to intersect, but I can't tell by my scale here where that is. So you have to choose your numbers correctly in order for them to graph. So this isn't going to work. I can't use 1, 2, 3, 4, 5, 6, and I can't use 2, 4. That's not going to work. They don't They do intersect, but just not on the scale I gave. Let's take all that off.
5, 10, 20.
Yeah. All right. So let's instead maybe count by every other square here and go 1, 2, 3, 4, 5. Right? And then here we can count by 5s. Yeah, so I'm going to do 10, 20, every other will be another 10. And there's really no way of knowing where they're going to intersect ahead of time. So you might have to do several trial runs if they don't give you the scale. It's okay. Try to get away from, well, I want to make sure it's the right one the first time I try it, not have to erase. Just, it doesn't take too long to erase it and try something else, okay? So better than just guessing and hoping. So now let's try graphing Rob. So starting at 20 still, and we're going up $2 for every DVD. So up $2 for every DVD. So this is 25, so up 2 would be right here, and then 1 DVD. There's 1. Notice how it's not up 2 squares over 1 square because of our scale. So up 2 more would be 24 for 2, 26 for 3, 28 for 4, and 30 for 5. Makes sense, going up $2, $2 at a time. Now Chad is cheaper to start off with. Starts off at $10, but goes up $4 for every DVD. $4 for every DVD. So up $4 would be 14 for the first one. 1 DVD would be $14. Two DVDs would be 18. 3 DVDs will be 22. 4 would be 26. And 5 DVDs will be $30. So here you can see that break-even point. So from 1 DVD to 5 DVDs, Chad, the red one here, is cheaper. So if this company or this dance team here only wanted 5 DVDs, they would totally go with Chad's company. Because you can see this line is below, which means it's less expensive. But then after 5 DVDs, Chad's is more expensive. So if they're going to make more than 5 DVDs, they better go with Rob's company. So, answer the last questions. When will the 2 options be the same cost? Okay. How many DVDs? As we can see from the graph, after 5 DVDs, they're the same cost. And what is that cost? $30. That's where they intersect. $30. So in general, we'd say, well, that's just 5 comma 30, x comma y. But we have to know, what does that 5 stand for? What does that 30 stand for? Okay. And this is what you're going to be doing. This is always the question. I mentioned before, you're going to find out another way of solving this problem that doesn't require graphing. Okay? That's what's coming up tomorrow. It's like, well, what if this was not nice numbers? $19.95 and it's $2.95. Couldn't really graph that. What would we do? Okay. Yeah. So